Hi, everybody. My name is Travis Kowalski, and I'm a mathematician at the School of Mines, and I'm going to be talking to you about how real numbers are categorized and how you place them. And so I've got here a badly drawn version of a Venn diagram that I think you're all going to see or going to get familiar with that has the different types of real numbers on them. So the very, very most basic real numbers are the counting numbers, the 1, 2, 3, 4 numbers that we learn to count with. And then when we add 0 to that group, then we have what are called the whole numbers, the positive counting numbers plus 0. If we take those numbers and we add their negatives, so negative 1, negative 2, negative 3, that collection is what are called the integers. And then if we have numbers who can be written as a fraction of two integers, like 1 over 2, 1/2, or 3 over 7, 3/7, then we call those numbers the rational numbers. And the rational numbers are sometimes thought of as being the numbers whose decimal expansions either stop, like 1/4 is 0.25, or who repeat forever and ever, like 1/9 is the decimal, 0.111111, repeating. And then if you've got a real number who's none of these things, then it's called an irrational number. And it's kind of hard to articulate what an irrational number is, but they're the numbers whose decimal expansions never terminate and never repeat. And so what we're going to do is I'm just going to give examples of numbers, and we're going to try to figure out where those things ought to fit. So for example, if we had something simple like 2, well, 2 is one of our counting numbers, 1, 2. And so 2 would fit right here in the counting number bit. If I stick a negative in front of it, then that would be the opposite of a counting number, which is one of our integers. So I'd put negative 2 right here. On the other hand, if I change that negative to a square root symbol, then I'd be looking at the square root of 2. And so that's the number whose decimal is 1.414 and change. And that's a non-terminating, non-repeating number, so we'd stick root 2 down over here. So let me erase this and start with something different. So let's say that we had something like, I don't know, let's see, I'm trying to do this upside down. There's a 5. So the number 5, that would be a counting number. It's a positive integer. If I had 5 divided by 2, then that's a number who's written as one integer divided by another integer. So that would make it a rational number. This is the number 2.5. And so that guy would fit over here. So 5/2 would be one of our rational numbers. Now I could be a little bit tricky, and I could actually talk about this guy, 5 divided by 1. Now that looks like it's a rational number because it's one integer divided by another integer, but 5 divided by 1, that's just a silly way of writing the number 5. So sometimes real numbers can be written in a disguised form. I could write the natural number 5 in a way that makes it look like it was supposed to be a rational number. But 5 over 1 is still a counting number because it's the exact same thing as 5. It's just a different paint job on that number. All right, let's take a look at some other numbers here. So let's start with something easy. There's 15. So 15 is a positive integer. That means it's a counting number. It's one of the numbers we can count on our fingers. But if I put a percentage symbol in front of it, 15%, now I got to figure out what kind of number that is. So you might know that percent just means per 100. So this is 15 divided by 100. And so when I write it like that, that's one integer divided by another integer, which would make it look like it's a rational number. And even if I write its decimal approximation down, it's 0.15. And that's a decimal fraction who terminates after 2 digits. And so that means that 15% is a rational number. It's a ratio of 2 integers. It's a real number whose decimal expansion stops after 2 digits. All right. Let's erase all of that stuff. All right, let's try the number 6. That's easy. 6 is one of the numbers we can count on our fingers, so that puts it down here in the counting number bit. Now, if I stuck a negative in front of that, then that number right there is going to be the opposite of a counting number. So it's an integer. If, on the other hand, I replace that with a square root symbol, now I've got the square root of 6. That's not one of the numbers that I kind of know off the top of my head, but I know that if I square 2, 2 squared is 4, 3 squared is 9. This isn't a nice, easy number to know, and so that's going to make it an irrational number. Now here I'm going to get tricky. I'm going to wedge a 1 in between here. So now I've got the square root of 16. So again, this looks like it's going to be one of these irrational numbers because those are the numbers that we sort of associate the most with being irrational. But the square root of 16 is just a fancy way of writing the number 4, because 4 times 4 is 16. And so the square root of 16 is actually way, way, way down here in the most basic of numbers. It's a counting number, because it's just another way of writing down the number 4. So that's sometimes one of the trickiest parts about trying to place your real numbers, is you can't look at just this format right here. You've got to figure out what that number really, really, really is. All right, let's try this one. Let's say that we had, say, 2 divided by 3. I think I've written those the right way. So 2 divided by 3, that would be one rational or real number, one integer divided by another integer, which would make it one of the rational numbers. Its decimal approximation is 0.6 repeated, and so that definitely puts it in this camp. There's a 2 and a 3. Now, if I stuck a negative out in front of this, negative 2/3, so negative 0.6666 repeating, that's still one ratio of an integer divided by another integer, and so that guy would also be over here. Here's negative 2/3. He'd be another one of these rational numbers. But if I stuck an extra 1 in there, I keep sneaking in these extra ones, so I have negative 12 divided by 3. Well, that is one integer divided by another integer, but when I write this guy out, negative 12 divided by 3 is nothing but negative 4. And negative 4 isn't one of these guys. Well, it is. It's a rational number, but it's even more than that. It's actually just an integer. And so this negative 12 over 3, which is the same thing, I'm writing my equal signs downwards, is a negative 4 there. And so you've noticed I've been able to place things all over. Here's a number we haven't talked about yet, but I'll stick them in there because we all kind of know about pi. We can put pi over there in the irrationals. And if I make a number whose decimal never terminates, so 1, 2, 3, 4, 5, 6, and just imagine that going on forever and ever, that would be another one of my irrational numbers. So I've managed to get people in this whole list, except for somebody who lives in this camp right here, a whole number who's not a counting number. And there's actually only one guy in this little spot right here, the number 0. And so there's a quick look at how you might place different kinds of numbers into their different partitions in the real number system. So thanks.